Hello and welcome to the application walkthrough videos for application pages 1 and 2 for integrated 1 for the Upward Bound summer class. Just wanted to give kind of some ideas on how to do some of these problems. I don't want to do them all, as this is one of the things that you are graded on, but I did want to give a little bit of guidance on some of these problems, at least the main ideas behind the problems. So the first thing we look at, we have perimeter on the first section. So this is application number 1. And we're looking for perimeter on the top. Now perimeter is the, you might call that the trip, let's say the trip around. So kind of the distance that it takes if you were to walk around the figure. So the trip around the figure, or distance, or whatever, whatever helps you understand that. And so each one of these has kind of a description as to what it is, and that's meant to help you a little bit. But there's also some other things that you might need to know based on some of the geometric ideas we're looking at. First one here is a scalene triangle. Just means that the 3 numbers are different. That's what scalene means, that the 3 sides, no sides are congruent. So if I was looking for perimeter of this, it would be the 3 sides added together, and this goes with the first part of your stuff for the day 1 material, which was adding and subtracting. So I would find perimeter of this by adding 5, 7, and 15. And you can add that in any order you want to. Shouldn't be too bad. The other important thing, and you can still see there's more names as we get through here. The important thing are what these little single marks mean. What they mean is, if I have one segment labeled with 1 mark and I have another segment labeled with the same marking, or just 1 mark in this case, it means that those 2 sides are congruent, or that they're the same size. So it would be hard if you didn't know that, or if you didn't assume that. It would be hard to know that this triangle here, the perimeter is what it is, because they only gave you 2 numbers and there's 3 sides of a triangle. So when we're looking for perimeter, our idea should be just add up all the sides and see what we get. You'll notice that marking idea, that congruence mark idea, happens in this equilateral triangle. Equilateral means that all 3 sides are the same length. So each one of these sides is 15. And on the isosceles trapezoid, means that the 2 legs of the trapezoid are congruent as well. So I'll leave that to you, leave that for you to tackle, but now you should have a better idea of what that means. And then also note that that single mark doesn't transfer from problem to problem. Just because there's a single mark here that's 11 doesn't mean that this single mark is also 11. It's based on each individual problem. Okay. And then a square just has 4 sides that are all the same length, so not to give too much away here, but all of those sides are 3. And rectangles, they're actually a specific type of parallelogram, and in parallelograms the opposite sides are congruent. So this side here is the same as this side here, and the same can be said for these. Okay. For the next section, it talks about area, and we're finding areas of squares and rectangles. I made it pretty straightforward for us on this one. Squares, rectangles, and parallelograms. And the area formula for any of those is base times height. It's based on the area formula for a parallelogram, and then using the idea that squares and rectangles are just special parallelograms. So in this one, we're going to be multiplying. So we're multiplying base and height. And, you know, you can think of any of these as the base and any of them as the height. I would kind of focus on ones that you have. Let's say this is my base. I'll underline that in red as well. And for my height, let's use that one right there. So then your area is going to be, I'm actually going to, don't want to do that. Let me just lock that in place so I can do this. So area is going to be my base times my height. Okay. And I would probably go with the same idea on the rest of these. It doesn't matter where your base and height is. The important thing is that your base, let's call this 8 the base and 6 the height. You could have switched those around. But the important thing is that those two sides meet at a right angle. That's what makes something, specifically that's what makes something a height rather than talking about the base. But it definitely, it talks about the two of them together. The next couple are pretty much the same, just base and height. Find the base, find the height, and move on from there. The last two are parallelograms, but the same rule applies. Okay, I can have a base, say that my base is 9 yards, and my height is defined as the perpendicular distance between the two bases. That's what makes something a height. And since I have this right angle right here and this 4 yards given, that's going to be my height. Notice that the base doesn't include this spot right here because that's not how long the base is. The base is only 9 yards. We actually don't care how long that is. And at the current moment, we're not really set up to be able to figure that out. So regardless, you're just going to find area as the base times the height. Hopefully that helped, and we will see you in class. Have a good day.